The only reason that we use text and not diagrams or programs is that in the 1950s, computer hardware could handle text, but couldn't handle vector graphics. We developed more modern technologies for non-programmers, but programmers themselves are still stuck in the 1950s. Worse yet, 1950s computers could only handle text that was arranged on grids of non-overlapping fixed-size bitmaps. Well, the other reason for using textual programming languages is that we are used to using writing technologies based on clay tablets. After 2,000 years, we've progressed to using graphite and rubber on paper. We didn't imagine that computers were something other than better clay tablets. Our continued use of 2D writing technologies has severely limited the way we think about things. We write equations in 2D to express simple physical concepts like sound that are actually 4D phenomena, X, Y, Z, and T for time. Mathematics seems complicated to many people because it is not natural and is a roundabout way of describing multidimensional phenomena that we experience daily. Complexity comes from the fact that we try to describe 4D effects by collapsing them down to 2D. For example, mechanical engineers are taught to draw multiple 2D views of simple 4D objects, top, front, side, and simply ignoring time. Computers allow us, for the first time, to express and explore at least 4 dimensions of our reality. We can shift the camera perspective on a 3D model and walk around it, and we can watch models evolve over time. We couldn't do this easily with paper and other clay tablet technologies in mathematics. The key word here is easily. Mathematicians and physicists are able to build 2D models of real phenomena, but only a select few can understand what's going on, usually after several years of university training. It seems that our notions about programming are based on the idea that if it's good enough for mathematicians, it must be good for programming too. Further, note that it is just plain hard to draw a sensible diagram using asynchronous function-based language. It becomes laughingly simple to draw diagrams if you use 0D components.
Question: why can we draw diagrams of computer networks?
Because each node on the network is essentially a 0D component.
Why don't we do everything this way?
Because of our built-in fear bias regarding efficiency. We are preconditioned to worry about saving bytes instead of saving development time. Without handcuffing ourselves with clay tablet 2D technologies, we could trickle down better apps to end users, but we don't. Further, computers in 2022++ are fundamentally different from computers in the 1950s. In the 1950s, each computer had only one CPU and limited memory. In 2022++, we want to build distributed systems such as blockchain, IoT, robotics, internet, etc., etc., etc. Ideas from the 1950s don't map very well to 2022++ computers, but we continue to force ourselves to use ideas from the 1950s. From a product design perspective, modern CPUs are little more than fancy FPGAs. Modern CPUs don't deserve all of the adulation we heap upon them in the form of creating sciences for building 1950s UIs, also known as programming languages, and 1960s IDEs, also known as operating systems. Our end users suffer from our tools' deficiencies. We insist on having end users pay premium prices for bloated operating systems, and we insist on having end users accept the fact that whatever they buy will be buggy without recourse in law. Real engineers are forced to take courses in tort law and are reminded of their obligation to produce bug-free products lest they be sued. For example, in Canada, engineers are given iron rings on graduation to remind them of a buggy bridge design that turned out to be fatal.
Sigh.